Here are the top 10 most important angle theorems that you have to know. Make sure you watch till the end where I give you a quick test to see how well you understand these theorems. Must know number 1, complementary and supplementary angles. Let's start with complementary angles. Complementary angles are two angles with a sum of 90 degrees. And if you were to put two complementary angles together, they would form a right angle. If I were to draw two line segments that form a right angle, and then break that angle up into two different angles, let's call them angle A and angle B, because these two angles combined together form a right angle, I know the sum of those two angles is 90 degrees, which means those two angles are complementary. So let's do a quick example with complementary angles. In this example, it says to calculate angle theta. If I zoom in on this diagram, we can see that the 70-degree angle and angle theta are complementary, because together they combine to make a 90-degree angle. So I could say that theta plus 70 equals 90 degrees. So to calculate theta, I just have to find the difference between 90 and 70, which is 20 degrees. Now I'll zoom out and we'll talk about supplementary angles. Supplementary angles are two angles with a sum of 180 degrees. When supplementary angles are combined, they form a straight line. So if I were to draw a line segment and break up one side of that line segment into two different angles, let's call them angle A and angle B, notice that when combining angle A and angle B together, they form a straight line, which means that angle A plus angle B equals 180 degrees, which means angle A and angle B are supplementary angles. And let's do a quick example with supplementary angles. In this example, we need to calculate angle theta again. So let me zoom in and notice that angle theta and 70 degrees combined together form a straight line, so they're supplementary. That means that angle theta plus that 70-degree angle would have to equal 180 degrees. So to calculate theta, just find the difference between 180 and 70, which means that angle theta would be 110 degrees. So I'll zoom out so you can see that whole section, and let's continue on where we learn angle theorems that involve other shapes and also parallel line theorems. Must know number 2, sum of angles in a triangle and other polygons. Let's start with the sum of the angles in a triangle. The sum of the three interior angles of any triangle will always be 180 degrees. So in this triangle that I'm drawing that has interior angles, let's call them A, B, and C, I know that the sum of those three angles is 180 degrees. So let's do a quick example involving the interior angles of a triangle. In this example, I need to calculate angle theta. And if I zoom in, I see that I know two of the interior angles of a triangle, and I'm looking to calculate the third. Well, I know all three interior angles of a triangle always add up to 180. So to calculate theta, I just have to subtract 70 and 75 from 180. And that would tell me that angle theta is equal to 35 degrees. Let me zoom out, and now let's do the sum of the angles in any polygon. To find the sum of the interior angles of any polygon, you can just follow the formula, which says do n minus 2 times 180 degrees, where in this formula, n stands for the number of sides that the polygon has. So if I were to draw a polygon with 5 sides, and then I'll label the 5 angles of that polygon, angles A, B, C, D, and E, I know that I could figure out what the sum of those 5 angles would be by using this formula, where I just sub in 5 for n because this polygon has 5 sides. So I would do 5 minus 2 times 180 degrees. That's 3 times 180, which is 540 degrees. So the sum of the interior angles of this pentagon would be 540 degrees. And now let's do an example where we calculate the measure of an interior angle inside of a 4-sided polygon. In this example, we have to calculate angle theta. So let me zoom in on this polygon. And because this polygon has 4 sides, I know that the sum of the 4 interior angles would be equal to n minus 2 times 180 degrees. So in this case, the number of sides is 4, so 4 minus 2 times 180 degrees. So the sum of the 4 angles would be equal to 2 times 180, which is 360 degrees. So to calculate angle theta, I would just have to subtract those three angles from 360, which would mean that angle theta is 111 degrees. And let me actually leave you with a note about the exterior angles of a polygon. The sum of the exterior angles of any polygon is always 360 degrees. So let me just zoom in here and give you a really quick diagram of what that would look like. So if I had a triangle, and if I were to extend the three sides of that triangle, the exterior angles, which I'll call A, B, and C, would all add up to 360 degrees. And that would be true for the sum of the exterior angles of any polygon. So I'll zoom out so you can see that whole page, and let's continue moving on. Must know number 3, the isosceles triangle theorem. This rule states that if two sides of a triangle are congruent, then the angles opposite from those sides must also be congruent. So I'll draw a triangle that has two sides of equal length. I'll label the vertices of this triangle A, B, and C. These tick marks indicate that the length of side AB and the length of side CB are equal to each other. Because those two sides are equal in length, based on the isosceles triangle theorem, I know that the angles opposite from those two sides, so angle A and angle C, would be equal to each other. So I could say that angle A equals angle C. And then let's do a quick example. In this example, we have to find the measure of angle theta. Because the measure of those two side lengths are equal to each other, I know that the measure of the angles opposite from those two sides would have to be equal, meaning that this angle here must also be 35 degrees. And then the sum of the three interior angles of a triangle has to be 180. And then I could calculate theta by subtracting those two angles from 180. And that would tell me that angle theta is 110 degrees. Must know number 4, the exterior angle theorem. This rule states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So if I were to draw a triangle, and I'll label the interior angles angles A, B, and C, and then if I extended one of the sides of this triangle, this angle outside of the triangle, which we call the exterior angle, I could label angle D, and then what you need to know is that this exterior angle D is equal to the sum of the two opposite interior angles. So D would equal angle A plus angle B. There would be two easy ways for me to prove to you why that is true. First of all, notice that angle D and angle C, when combined together, form a straight line, meaning they're supplementary, so they add to 180 degrees. But also I know that all three interior angles of a triangle, when added together, also has to be 180. Notice adding two different things to C, either D or A plus B. When either of those are added to C, we get 180. So that must mean that D and A plus B are equivalent to each other. Hence the exterior angle theorem. Another rationale would involve some parallel line theorems, which I'll get to later in this video actually, but I'll give you a brief preview of it now. If I were to redraw a line parallel to this side, starting here at angle D, there's an alternate angle theorem, or the Z pattern, which would tell me that this angle and this angle are equal. And there's a corresponding angle theorem, which would tell me that this angle in here is exactly equal to this angle. So that would equal angle A. So you can see that angle A and B perfectly make up angle D. Now a quick example. In this example, I have to find the measure of angle theta. Based on the exterior angle theorem, I know that this exterior angle, 110, would have to equal the sum of the two opposite interior angles. And then I can solve for theta by subtracting the 40 from 110. And that would tell me that theta equals 70 degrees. Must know number 5, the vertical angle theorem. This rule states that when two lines intersect, the measure of the angles opposite from each other are equal. So if I were to draw two lines that intersect, I'm actually creating 4 angles. I'll call those 4 angles angle A, angle B, angle C, and angle D. The vertical angle theorem tells me that the angles opposite from each other are equal in measure. Since angle A and angle B are opposite from each other, I could say that the measure of those angles are equal. And because C and D are opposite from each other, the measure of those angles are also equal. So a really quick, easy example. It asks me to find the measure of angle theta. Well, I notice I have two lines that are intersecting, so the angles opposite from each other, theta and 61, must be equal to each other. So for that one, we could just state theta equals 61 degrees. Must know number 6. Alternate angles. This is our first parallel line theorem. If two parallel lines are cut by a transversal, the alternate interior angles are equal, and the alternate exterior angles are equal. Let me draw a diagram to show you what I mean. Let's start with the alternate interior angles. I'll draw my two parallel lines, and then I'll cut them with a transversal. That means I'll draw a non-parallel line which intersects both of those at two distinct points. In this diagram, I have 2 points of intersection. The interior angles are the angles between those points of intersection, so these 4 angles in here. Let me name those angles. I'll name them A, B, C, and D. What this theorem tells me is that the alternate interior angles are equal. At this point of intersection, if I choose this interior angle A, to find an angle equivalent to it, I go to the other point of intersection and find the angle on the opposite side of the transversal. So here, angle C. So angle A and C are equivalent to each other. And you'll notice if I draw the letter Z, it can make it easy to find these two angles that are equivalent to each other. That's why this alternate angle theorem is sometimes called the Z pattern. And then if I made a Z going in the other direction, the angles inside of that Z are B and D. So those angles are also alternate interior angles, so they're also equal to each other. Now, not only are the alternate interior angles equal, but so are the alternate exterior angles. So let me draw 2 more parallel lines here, and I'll cut them with the transversal as well. Here's my 2 points of intersection. The exterior angles are these 4 angles outside here. I'll label them E, F, G, and H. To find an angle equal to this exterior angle, I go to the other point of intersection and pick the angle on the opposite side of the transversal, so H. So E and H are equal to each other, and for that same reason, F and G would also be equal to each other. So let me make some room, and let's do an example where we can practice finding this parallel line theorem. In this diagram that I'll show you, let's find the measure of the indicated angles. So we need to find angle X and angle Y. I notice that X and 110 degrees are alternate interior angles, and I can draw that Z pattern so you can see that. Notice how they're both angles inside of that Z I drew. So I can say that X is equal to 110 degrees. The next thing I notice is that angle X and Y are supplementary. Those two angles form a straight line, so I know they add up to 180 degrees. And I know angle X is 110, which means angle Y must be 70 degrees. Must know number 7, co-interior angles. This is our second parallel line theorem. This theorem states that interior angles on the same side of a transversal add up to 180 degrees. So let me draw a diagram of this theorem. I'll draw my 2 parallel lines, and I'll cut them with the transversal. And now I need to label the interior angles on the same side of the transversal. So I'll go to the right side of the transversal, and I'll label these 2 angles, we'll call them A and B. Because they're the interior angles on the same side of the transversal, I know they add up to 180. And this theorem is sometimes called the C pattern. And if I draw a letter C, you can see that these 2 angles are inside of that letter C. So that's why it's called a C pattern. And now let me do an example where we try and identify that C pattern. Let's find the measure of angle theta in this diagram. Since these are both the interior angles on the same side of this transversal, I know they add up to 180 degrees. And let me draw that C pattern so you can clearly see that. So I know that theta plus 75 would have to equal 180 degrees. Subtract the 75 over, and I would figure out theta must be 105 degrees. Must know number 8, corresponding angles. This is our last parallel line theorem. This rule states that angles which occupy the same relative position at each intersection of the transversal with the 2 parallel lines are equal. So we'll draw the two parallel lines, the transversal, and show you what I mean by this. At each of these points of intersection, there are 1, 2, 3, 4 angles. Let me label all of those angles. And at each of those points of intersection, the theorem tells me that the angles which occupy the same relative position are equal. So if I go to both of those points of intersection and pick the top left angle, those would be equal to each other. So I know angle A would be equal to angle E. And if I do the same thing, but I pick the top right angle at both points of intersection, those would be equal to each other. So angle B is equal to angle F. Same thing with the bottom left angles, D would equal H, and the bottom right angles, C would equal G. Now, sometimes this rule is called the F pattern. It's sometimes called this because if you're to draw the letter F, it can help you find the corresponding angles that are equal. The angles underneath the horizontal lines of this F, C, and G are equal to each other. Now let's try an example where we can use this relationship of corresponding angles. Let's find the measure of angle theta in this diagram. To find theta, I noticed that theta and 41 degrees are equivalent because they're corresponding angles. And I can see that more clearly if I draw the F pattern. In that F pattern, I know these angles inside of the F are equal to each other, so theta must equal 41 degrees. Must know number 9, angles subtended by an arc. This is our first circle theorem. The rule states that inscribed angles subtended by the same arc are equal. So let me show you what that means. I'll start by drawing my circle. And then let me outline part of the circumference of this circle as my arc. If I were to inscribe any two angles inside of this circle that are subtended by that arc, they will be equal. So what does that mean? To inscribe an angle subtended by this arc, that means pick any point on the circumference of this circle. I'll pick right here and draw two line segments that intersect the arc at its endpoints. So here and here. The angle I've created is the angle up here at the circumference. I'll call it angle Y. If I follow that same process, but do it from another point on the circumference, so over here, as long as I draw segments that go through the endpoints of that same arc, that angle at the circumference, which I'll call X this time, is going to be equal to the other one, Y. So angle X and angle Y are equal to each other because they're subtended by this same arc. There's another interesting circle theorem that's very related to this one, that says that an angle inscribed in a semicircle actually equals 90 degrees. Let me show you what that looks like. So once again, I'll draw a circle. And since this theorem is about a semicircle, let me draw a diameter line through the middle of this circle to cut it in half. Inscribing any angle inside of this semicircle is going to make the angle equal to 90 degrees. So to inscribe an angle, I pick a point on the circumference and then draw line segments to each of the endpoints of this chord that I've drawn of that circle. And this theorem tells me that this angle here is guaranteed to be 90 degrees. So let's try an example now. Let's calculate theta in this diagram. In this diagram, I notice that this angle and this angle are both subtended by the same arc, that arc right there. Angle theta is subtended by that arc, and 65 is subtended by that arc. So for that reason, I know that theta and 65 are equal to each other, so I could say that theta equals 65 degrees. Must know number 10. The angle at the center of a circle versus the angle at the circumference of a circle. This rule states that the angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the circumference of the circle. So let me draw that in a diagram. In this circle, if I draw an arc length, I'm now going to create two angles that are subtended by that same arc length. I'm going to create an angle at the center of the circle first. So starting at the center of the circle, I'll draw two line segments that go to the endpoints of the arc. And now I'll inscribe another angle in this circle by choosing a point somewhere on this circumference of this circle. I'll pick it over here. And now I'm going to draw a line segment that goes from that point to each of the endpoints of that same arc. Now what this theorem tells me is that the angle at the center of the circle is going to be double the angle that's at the circumference of the circle. So if the angle at the circumference of the circle is, we'll call it angle X, the angle at the center of the circle would be double that. I could call it 2x. And now let's use that relationship to solve this example. Because I noticed that both of these angles are subtended by this same arc, I know that the angle at the center of the circle has to be double the angle that's at the circumference of the circle. So 142 is equal to 2 times x. And then to calculate x, I could just cut 142 in half. And I would figure out that x is equal to 71 degrees. Now that you know the 10 most important angle theorems, test yourself out. See if you can find all of the missing indicated angles in these 3 questions. Leave your answer in the comments. I'll make sure to like a comment that has all of the right answers for you to be able to check your answers against. Also, let me know what top 10 do you want to see next. Jensen Math!